Okay, so let's get this second term as well from these equations. Okay, and then our proof is gonna be complete. Right. So let's first of all write this the gradient of f. Okay, so it is gonna be del x f x cap plus del y f y cap plus del z f z cap, right? And what will happen if we, okay, no, here I made a mistake. Actually I think uh, it is gonna be a instead of this gradient. Okay, so it is going to be a. So if it would be del cross del of f, it is going to be 0, as we will see from our next video, where I am going to explain the product rule for the second derivative, right? So this is the second derivative because we are taking this del operator twice. Okay, so we'll see in the upcoming videos about this. Okay, so now, so this is a, right? So let me remove this. Okay, a cross del of f, what it is going to be. So what I am doing, I am just expanding this into the component form and compare this with these remaining term in the LHS, right? These red terms in the LHS. I'm sorry, yeah, okay, yes. And if it will give the same term, then that this term, rearranging this term, must give this second term, and then we are going to have our proof ready. Okay, so what it is going to be, yeah. So let's write x cap, y cap, z cap, ax, ay, az, del xf, del yf, del zf. Okay, so for the x component we're gonna have ay del zf minus az del yf. For y, we'll take I will take the plus sign over here, and will manage the minus sign in the inside. So az del xf minus ax del zf. So it is actually del z plus z cap ax del zf minus az del xf. Okay, so let's see, do we have the same terms? Right, so I'm using the green marker. Az del yf, first of all, for inside I mean this del operator is this derivative is acting on f in all of these components, right? Yes, we have this del acting on the f in all of those components. Yeah, for the x component, I mean del x, there will be y, and for the again for the del x there is z. So for the del x we have z, one thing is this. For the del x we have, okay, I think there is some mistake. No, that's fine. For del x we gonna have y, for del x we gonna have z. Okay, this is the first thing. For del x we gonna have y, and for del x we gonna have z. Okay, let's first of all let's compare the other terms. For del y we gonna have ax del y f, ax del del z az del yf, az del yf. Okay, az del yf, del yf, right. And then we are gonna have this okay, yes. One thing that I forgot over here is that there is a minus sign, right? And I forgot to include the minus sign over here, so we're gonna have minus sign over there, and we're gonna minus sign over there, minus sign there. So all the plus term will have minus sign, and the minus term will have plus sign, right? Now we can compare it. Okay, so minus ay del z f minus ay del z f. Yes, we have, this is the minus sign. Okay, so first term matches. Az del yf, az del yf with the plus sign. Yes, we have plus sign. Minus az del xf, minus az del xf, ax del zf, ax del zf, and these two will also match. You can see it. Minus ax del zf, minus ax del z. Okay, minus ax del zf. I think this should not be z. Okay, I think there is some mistake. Okay, let me correct it. So what is it? For the z, we gonna have ax del, yeah, so we ax del yf, and for that we gonna have ay del xf, right? And we can completely compare all of this thing. Minus ax del yf, minus ax, where is it? Minus ax del yf, and then ay del xf, ay del xf. Yes, so everything matches. So we have finally proved that the curl of a vector which is formed by the multiplication of vector with a scalar is actually the curl of first vector, I mean the curl of that vector times the scalar minus taking the cross product of vector with the gradient of that scalar. Okay, so we have proved this, and then I will begin the second identity. Okay, so I'll prove it in the next video, but let me begin it here itself. So this is the second identity, which is gonna be the curl of the cross product of two vector. Okay, so it is going to be b dot del acting on a minus a dot del acting on b plus a times del dot b minus b times del dot a.